In the last few classes, we talked about orthographic projection, isometric projection, isometric drawing, and orthographic drawing a bit. And that was part of descriptive geometry. You have already studied about plane geometry and solid geometry in your 11th and 12th classes. This is also part of solid geometry. Today, by continuation of that technical drawing, discuss perspective drawing, perspective projection or perspective view. Now, by definition, perspective projection is representation of an object on a 2D space or on a plane or on a piece of paper as it would appear to our eye or as we perceive, right? Now, in other words, if you look out of the window and put the tracing paper or any transparent piece of paper on the glass of the window and just draw the outline of the object that you are looking at, you will get the perspective view or perspective drawing. Or you can take a camera or even your mobile camera in a default mode, just click the photograph, the image that you will get, that will be perspective view. Obviously there is some relationship between the distance from the object and observer and picture plane that we will discuss later. Now let's discuss the procedure or techniques to draw perspective drawing or perspective projection. Now I have two-dimensional object or just a simple plane. Now this plane I am just keeping vertical, not inclined. Now if you see carefully, if I move towards the camera or towards the observer or eye of the observer, it looks bigger. Now if I am moving away from the observer or eye, it looks smaller, right? Now let's take as a first case. Now let me draw. Now this plane that I am keeping vertical, I am keeping somewhere here. This is the eye of the observer, or we can say the station point. Now this is picture plane. Picture plane is nothing but the vertical transparent plane on which we are getting the image. Okay, now if I draw the perspective view of this plane. Now this plane I am keeping perfectly vertical. Suppose the height of this vertical plane is L. Suppose from here to here, this height is L. This is true length of the vertical plane. This length I am talking about. Now this is the picture plane. We can write PP. This is station point. Now this is station point. This is picture plane. This is the object. Now here, from the eye, I am drawing a ray to the upper part of this object and to the lower part of the object. Now if you see carefully, this ray is going to cut somewhere here and this ray is going to cut somewhere here. So the image I am getting on the picture plane is this one, right? The true height of this plane is L, but we are getting only this much. This could be, we can write small l. So obviously this small l will be less than capital L. Now this vertical plane I am moving away from the station point. So suppose I am keeping it somewhere here. Now I am keeping the vertical plane somewhere here. So again true length will be L. Now if I draw the ray from here to the station point and from here to the station point. So the picture I am getting at the picture plane will be this much. Suppose this is L dash. So again L dash will less than the small l and it will be obviously less than the capital. Now we are very clear, if I move the object or plane away from the station point, it looks smaller. If I move towards the station point, it looks bigger, like this. Now let's put this vertical plane at the picture plane. Now I am putting this vertical plane at this picture plane. So obviously we will get true length. This will be L. That means this will be L. Now we have clear understanding. If I move the object away from the picture plane and away from the station point, it looks smaller. If I move towards the station point or towards the observer, it looks bigger. And if the object touches the picture plane, you will get true length. Now let's see again in the camera. This is the vertical plane. If I move away from the observer, it looks smaller. If I am moving the object towards the source or towards the eye, it looks bigger. And when it touches the picture plane, it gives true length of the object. Right? Now if you ask how to get this dimension, this width of the object, the height we can get it from the side view. This is the side view. Now if I draw top view, suppose this is picture plane and this is the object, and here we have station point. So if we draw the ray from this point towards this station point, again from this point towards this station point. So if you see carefully, this is picture plane, this is the object, and this is station point. So if you draw the ray from this point to the station point, it cuts the picture plane somewhere here, and if I draw from this point to this point, this cuts the picture plane somewhere here. Now I can take the projection from here and again from here. So this will be the final view of the object. So width I can get it from here. This is top view. And this is the side view. This height of the object or height of the picture, we can get it from this side view. This is the station point, this is the object, this one is picture plane. If I draw the ray from this point to the station point, from this point to the eye, it cuts the picture plane somewhere here. So this height we can get it from side view. Now if you ask the width, we can draw the top view. This is the station point, this is the object, and this is the picture plane. I can draw the ray from this point to the station point, again from this point to the station point. It cuts the picture plane here and here, and then I can take the projection. I will get this view of this plane. The technique or procedure to draw perspective projection or perspective drawing we'll discuss later. Right now we will try to understand how the object will look like with the different positioning.